we're going to dig into some provocative thoughts and questions about robots. For example, how many here are maybe worried robots are about to take all of our jobs and all of the jobs, right? This is classic panic in 2018. We're going to explore whether or not that is actually happening. How about the Robo Apocalypse? Anybody worried about the Robo Apocalypse? Robots all of a sudden are smarter than us. Then they not only take our jobs, but take our humanity. Maybe that's going to happen. Maybe it's not. I don't know. We got some people who are involved who are going to look at that. How about human-robot romance? Is that coming? Is it happening already? All right, we're going to discuss that. So it should be a fun night. I want to introduce our speakers. We've got three folks who are going to come up and share a little of their story and expertise, all in this field of robots. We've got, there's one right here. This is Joelle Renstrom. Joelle, can you kind of, let's hear it for Joelle Renstrom. Joelle is a science writer, and she writes primarily about space and robots, but not a fiction writer. That's important, I think. You know, she understands this topic and is looking at, you know, how we're sort of, what are robots doing all over the world, and she has a really good global sense of that. So, looking forward to hearing her insights. We've also got Nadia Cheng. Where's Nadia? In the back there. She's wave real big. Let's hear it for Nadia. Nadia has, I'm really excited about Nadia's talk because she's got a lot of practical experience. For over a decade, she's been working in the field of robotics at a whole bunch of different companies. So she's really going to give us a sense of what robots are being used for now, where that's going, what it's like day to day to be working with robots. And then we've got Sam Spaulding. Where's Sam? There's Sam right there in the blue shirt. Well, let's hear it for Sam. Sam is getting his doctorate over at MIT, and his specialty is human-robot, sort of how they interrelate with each other. So he's going to share a little bit of that. So I'm pretty excited about our speakers. What do you guys think? You guys into this? Yes. Yes. Excellent, excellent, excellent. All right. So our first speaker, as I said, he's getting his doctorate at MIT, and his specialty is how robots and humans interact, the interaction between the two. So I think we're going to maybe touch a little bit on this for those of us who are worried about whether they're coming to take over or not. Maybe he can give us a reality check on where we're at with that. So let's please welcome to the stage right now our first speaker, Mr. Sam Spaulding.
All right, so I am a graduate student at MIT. I'm in the personal robots group there. And yeah, over the next 10, 15 minutes, I'll talk a little bit about human-robot interaction, which is kind of the sub-area that I work in. It's all about how to build robots that can interact with people the same way that we interact with each other, that can pick up on social cues, and that can do things a little more social intelligence instead of mechanical intelligence. So here we go. There's a whole bunch of different things that we do here in this field. We do artificial intelligence, software, programming, algorithms, that kind of stuff. We do robotic engineering. We actually build robots and sort of build actual physical things. And then we do studies of human behavior. We put these robots out in front of people, and we sort of study how people want to interact with them, how people do interact with them, how the robots interact with people. We sort of look through the robot's logs and things and say, well, what did it think was going on here? And we think there are all kinds of interesting applications for this. Some of the ones that we're focused on right now: education, like the idea of a robot that could be sort of like a personalized tutor, always there, like coaching you and kind of giving you personalized feedback. An assembly mate, like Jarvis and Iron Man, where you can work together to like build IKEA furniture or something like that, right? And then we're also, looking at the idea of aging, right? That a robot could be there to sort of help people age and live more independently for longer. That's a really sort of important application area, and it's something that we think robots can really help out with. So human-robot interaction, that's kind of the the high-level area that we're working in here. That's in contrast to sort of the typical view of robots, which for many years was sort of viewed as, robots do things, tasks that were called the 3Ds, jobs that were too dull, dirty, or dangerous for humans to do. So things like, building cars all day, or defusing bombs and things like that, sending robots into volcanoes, sending them underground to like check out, giant chemical plumes and things like that. Sending robots to Mars, obviously, these are all things that we couldn't send humans to do yet, but we can send a robot to do them. In contrast to sort of this view of robots, which is where the research world was for many, many years, most people in their sort of popular imagination of robots, they think about this kind of thing, right? A robot servant that's gonna come around my house and like clean my dishes and water my plants and clean up after me. So, that's a concept that's been in our sort of public consciousness for a while, but it's really quite far from reality. And so human-robot interaction is all about, how can we try to make this a little bit more real, right? And sort of connect the actual science and engineering of robots to these sort of popular notions of, socially interactive robots. So humans, of course, are very social, right? And even as babies, we're very sensitive to faces, we're very sensitive to gaze and gesture and things like that. We're very sensitive to facial expressions. We can tell when people are mad at each other just from a quick glance, or we can tell if people are flirting with each other and kind of like each other, right? Just because of these little gazes, glances, kind of postures and things like that. We're very, very sensitive to those things, and we sort of learn how to do these things automatically. And of course, we have the idea of social robots, robots that can also do these things too, robots that have personalities, that talk to each other, that sort of are very endearing, even charming. So these are the kinds of robots that we build. We build robots that are sensitive to those sorts of things. These are the kinds of cues that our robots are capable of picking up on. We can have robots that analyze people's facial expressions. We have robots that can sort of track your body pose and look at your skeleton. And so these are sort of computational technologies that are kind of new and just kind of coming into sort of widespread use. But that's what's sort of enabling us to actually build robots that can do all these social cues. So there's obviously, these robots are not fully there yet. These robots are very rudimentary. There's only really sort of a few things that these robots are capable of picking up on, and oftentimes not in isolation. So it's really just a small fraction of what humans are capable of doing. But that's sort of the fun of the field, is that it's so wide open, and there's a lot of different problems and areas to pick and research on. So this is kind of the big takeaway here, right? Is that what we learn automatically, humans, typically developing humans are very sensitive to these things, and somehow just sort of learn how to pick up on these skills and tell when people are engaged, when people are bored, when people are happy, when people are sad. But robots need to be taught or programmed to do all of these things. And so that's kind of the goal of my research, is to develop robots that know how to interpret these social cues. I'm gonna skip past this video just in the interest of time and show you one of the robots from our lab kind of putting it all together. So this is sort of what a robot that we have in our group called Leo is capable of doing, right? And you'll notice that there are a lot of things going on here between Matt, a graduate student, and Leo, the robot. So you can see, for instance, they're making eye contact here. Matt's kind of introducing this new object, and Leo's engaging in what we call joint attention. So joint attention is when two people are sort of sharing their attention together on something. They kind of understand there's this fixed interactive ground. Now Leo's also sensitive to the tone of Matt's voice. So from the way that Matt's describing this robot, or this puppet, Leo's kind of learning a little bit of something about what kind of a thing Big Bird is. So this is actually a really interesting social learning process that you see across the animal kingdom called social referencing. And it's a way that you can learn about new things by directly interacting with them, but you can also learn about new things by observing how other people interact with them or how other people describe them. So you'll notice that the way that Matt now describes Cookie Monster is very different from the way that he describes Big Bird, and Leo is going to learn about those two objects in very different ways. So far, so good. You know, we're introducing Cookie Monster. Leo, he's reaching out for it. Right. So Leo's learned that Cookie Monster is not a good thing, which is in stark contrast to what he learned about Big Bird. And he learned all of this just from the way that Matt, the teacher, kind of introduced it. So it's a very social learning process. It's the kind of stuff that crops up often in, you know, the way that parents teach their children or the way that people teach their pets. You know, you sort of talk about things and you use these sort of exaggerated tone of voice or exaggerated gestures and things like that, because that's actually what's communicating the information about what, you know, whether things are good or bad. So we're working to sort of implement that computationally in some of these robots in the hopes that that's going to be a way that they can learn about things in the world, because that's a little bit easier than programming all the knowledge, you know, into them from the start. So these are some other robots. You know, they're sort of smaller scale robots built around cell phones, you know, but the idea here is that since your cell phone has so much personal information on you anyways, why can't we build a robot around that that can take advantage of all of that? And it doesn't hurt that cell phones happen to be, you know, really very powerful computers nowadays, right? That have integrated sensors, microphones, cameras, connections to the cloud, you know, all this stuff. So why not build a robot out of that? So these are some robots that we've built that are all based around smartphones, and you can kind of see, right, each one of these is, you know, has a smartphone for a face, and then is kind of hooked up to a larger, you know, sort of electromechanical shell kind of thing. So we actually program these robots as apps. You download apps onto your phone, you hook them up to the robot and run it, and then it sort of, you know, comes alive just like this. So we take these robots out to schools, science fairs, hospitals, all kinds of different places. But what we're really excited about next is getting robots in the home. So it's not space, but home is actually the final frontier for robots. So this is a little clip for Gebo, which was a local Boston area startup that made social robots for the home. It was founded by my PhD advisor, and I actually worked there for a couple years. And we've got a Gebo over there at that table, so after the talk, if you're interested in coming by and checking it out, you know, robots are coming to your home. Now the technology is there. You know, the sort of impetus to kind of get robots. People are sort of seeing why these things are cool, interesting, unique, and you know, they're finally sort of ready to enter your home. But it's going to be a good thing. So I hope you're all ready. Yeah, you know, I guess maybe just a closing thought is the idea that robots right now are sort of where computers were in the 1970s. You know, they're sort of expensive, they're hard to use, they require sort of special training and things like that. But, you know, the costs of the technology and the sort of user interfaces and, you know, ability to interact with these robots, it's just going to get cheaper and easier. And so, you know, I wouldn't be surprised if you all had a personal robot of your own in 5 to 10 years. Come talk to me about it later. Thanks, everyone.
Let's hear it for Sam Spaulding. Big round of applause. Don't go anywhere, Sam. I've got some questions for you. Why? Why are we doing all this? Why do we want robots? Yeah, like yeah. Why? Why do we want to? Why is Katie Couric in that picture? Is that Katie Couric?
That is Katie Couric. She came to our lab.
No, but in all seriousness, like, yeah. Do we need them and why?
Yeah, well, I do think there are some great areas in which robots can really have a positive impact on people's lives. So especially these kinds of robots, which are what we call social robots. You know, in many cases, they can sort of play a role of social support. for people that don't have access to that. So for instance, in like Japan, for instance, they have a very sort of top-heavy demographic profile. So there are many more sort of elderly people in their population than there are people to take care of them, right? And so that's sort of causing a bit of what they are calling like a care crisis over there. And they, the Japanese, they're really into robots, and so they're sort of looking to robots as a way of, maybe making it so that people can live independently for longer, or, have access to sort of social support, or kind of be this like bridge that can keep them connected to society, even if they live alone.
So that video you showed, what was that Leo? Was that the name of that?
Yeah,
that
yeah, the furry one.
So maybe, I can't quite work out why. Maybe it's because he looked a little bit to me like Gizmo from Gremlins, right?
Yeah.
That there was like this part of me that was like waiting for the moment, even though he was like so cute, right? Where like they're teaching him about evil, and then he's gonna say, Leo is evil too, Matt, and then like attack Matt,
yeah.
right? Like so, obviously there's this like thing out there that we hear sort of discussed. That's kind of like a kidding way of getting at it, though, which is that these robots are going to learn to teach themselves, and then all of a sudden kind of spin out of control. Like, are we anywhere near that?
So I mean, no, right? Like we're not really at a point where
Deep breath in.
robots
Was anybody
are,
else worried about it, or was it just me? All right, a couple.
Yeah,
Me and
we're
like
not
three
really at a
people.
point where robots are, capable of existing on their own without a lot of human help, right? I mean, it takes a lot of work and a lot of engineering and a lot of time to get robots to work. Here at the lab or in people's homes, it just takes a lot of man hours of engineering to get these robots to run. In the early days when we were kind of first getting various prototypes up, it's a minor miracle if you can get a robot to work for a couple hours without, crashing, breaking, right? I mean, these are fragile, complicated bits of machinery. So they're not close to sentience. They're not close to full, lifelong autonomy. There are, only a few, probably 1,000 robotics engineers out there.
Is that true? Really?
Yeah, I mean,
why? It's sort of
a complicated
as somebody
skill, right?
Yeah. As on the outside, it's sort of in my mind. I'm like, there's robotic. Like you would think that there would be more.
Yeah. Well, depending on where you want to, draw the line, but if you talk about like the number of people that are sort of employed as engineers in the robotics industry, it's not huge, right? Not compared to other industries that employ tons of people. So it's a cool technology. It's a technology that's growing super fast, and it's sort of rapidly gaining in importance. But if you really think about what sort of impact robots interacting with people has, right? Or like fully autonomous robots that are being designed to sort of exist for long periods of time. It's a tiny fraction of the amount of time and energy that we spend on building other things, right? So I think if you just think about it as any other kind of technology, and you try to sort of apply the same frame of thinking to it as you do with any other technology, the the sort of worries and fears and things that you have about that seem a little more tame. Yeah, right. I mean, this is just this, robots, they tap into our psyche, and they have this really, they have a lot of cultural baggage associated with them, especially in the West, right? There's this, like the Frankenstein story is like, you're always afraid that the thing that you build is gonna like rise up.
It's gonna turn on you.
Yeah. But there are other cultures that don't have that, right? The Japanese, for instance, have a very positive sort of cultural association with robots and things like that. And, it shows in the way that they're sort of making plans about integrating robots in society. They don't really have these fears of it's going to rise up, it's going to kill us all, take our jobs, whatever, right? So
sounds like Japan's going down first. Yeah. I mean, that's what it sounds like to me. I'm just kidding. Sam Spaulding, everybody, let's hear it for him. One of those other fears that we talked about early on was that idea, are robots going to take all of the jobs, every single job that there is? None of us will be able to work, which maybe is not so bad if we can figure out a way to make money, whatever it is. But Our next speaker is going to, I hope, address a little bit of that and give us a sense of what it's really like in the day-to-day on the ground. As I said, she spent more than a decade working in robotics and a whole bunch of different industries. So she's going to share some of her story and perspective, I hope, for us. So please welcome to the stage right now, Nadia Cheng!
If I were a robot, I wouldn't be so nervous, I think, but I prefer being a human for now. So I got sucked into robotics a little over a decade ago, and one thing I like more than robots is people who like robots. So if you're here because you like robots, then we'll probably get along. And proof of that is I met my husband at NASA Robotics Academy in college, so I do like people who like robots. A little bit about my journey. So one of my first experiences working with robotics was in college at this internship. I worked with robots who work with kids who have autism. So really seeing the impact that robots can have on people was really inspiring. After that, I was, very motivated to work on assistive robotic technologies and medical robotics. I won't have a ton of that here because it was more like projects in school and that kind of thing. But so I went to grad school, didn't know what I wanted to do. I just knew I needed to keep learning, and I was really into mechanical engineering. So my advisor said, I just got this new project. They asked us to make a morphing cartoon blob. And he said, like Flubber. And I thought, oh, that sounds awesome. I didn't know how hard it was, but it's hard. So I'm not going to show you anything that looks like Flubber because we never got there. But this is something I worked on in grad school. So I'll start the video in a second. But so as part of our effort to make like a morphing cartoon blob, I spent a few years trying to develop tunable stiffness structures and materials. So the idea was, if you have this blob, you want it to do something useful, like do search and rescue, you might have to squeeze through tight holes, so you might have to be really squishy, and but then if you need to like lift something, you need to become strong and be able to carry some payload. So one of the concepts I worked on, which wasn't new at the time, but I focused on something called granular jamming. So if you imagine you have a balloon filled with sand, it's squishy like a stress ball, right? And if you vacuum pack it, it becomes rigid in that state. It's like a ground coffee you can buy in the form of a rigid brick. Once you puncture it, it flows. And so if you take like the stress ball, you can easily transition between really rigid states and really soft states. So taking this really simple concept, I designed and built these robotic arms. So basically you imagine you have like a chain of these segments, and you can selectively tune them, make them rigid or soft, and therefore control the shape of the whole thing. This video, you might see like maybe rated PG or R. Don't read the YouTube comments, but it's gonna, you'll see. This is a video of my a jamming manipulator. So it looks like a robot trunk here. So see in the bottom, we turn off the bottom, we soften the bottom segments, make the top ones rigid, and we pull some cables. And we have this, very flexible, floppy thing. And here's a, yes, self-explanatory. The YouTube comments are very, I don't know, it was, all right. So after grad school, I didn't know what I wanted to do, but I got really lucky. I knew a guy at Cornell. We graduated, so I was at MIT, he was at Cornell. We finished our PhDs at the same time, and he was using the same exact jamming phenomenon to create robotic grippers. So the idea is if you have you imagine some stress ball, if you want to pick something up, you put it in its squishy state, you push it up against the item, it passively conforms to it, you vacuum pack it, and it becomes this universal conformable gripper. So he started this company called Empire Robotics, and I was very lucky and got to keep working on what I worked on for my PhD, which is very unusual, especially in such a weird niche area. And so this is a demo of our product called VersaBall. So this is our squishy green blob. And we were targeting manufacturing here. So it's a startup. I was the first employee. And it was awesome. I love the team, but we realized how hard it is to be at a robotics startup, especially in manufacturing here, and I'm gonna, you'll see, I guess I can just jump to the next video, but there's been automation in manufacturing for decades. There's been robotic grippers in manufacturing for decades. And so we learned how hard it is to bring in something totally new and different to a really conservative industry that already has a lot of automated solutions. So yeah, things got slow, and I had to look for another job, and I thought, well, I'm not going to do robotic startups for a while, and that wasn't true. So I met with founder at RightHand Robotics and was immediately blown away. But I'll jump to what I'm doing now. So here's a video of automation and manufacturing. This is amazing. You have robot arms building cars. So you can see why it's so hard for our squishy gripper to get into this industry, right? I could never do what these robots are doing. I can't build a car. And so when you look at something like this, you think, wow, what job is there for me to do? So if there is one thing I want you to remember from this is that robots probably won't be taking most people's jobs anytime soon, despite what you see here. In manufacturing, you have robots doing the same thing millions and millions and millions of times over again. They don't have to be smart. The robot doesn't know what it's doing here. It's all hard-coded to do the same thing over and over again. And sorry, didn't give you much background. The company I'm at now is called RightHand Robotics, and we make robots for fulfilling e-commerce orders. Different industry than manufacturing, and it's, here is a video of different e-commerce fulfillment facilities, and it looks very different from the manufacturing facilities. You see a ton of people doing a lot of mundane tasks, but these are tasks that currently can only be done by people, because unlike in manufacturing plants where you're handling the same thing over and over again, in e-commerce facilities, you have hundreds of thousands of different products in the same facility. So if you bring a robot, basically the robot has to do hundreds of thousands of different things and handle products it's never seen before. So the challenge is if you put a box of items in front of a robot it's never seen before, how does it know what to do with it? Even if it has cameras, it can see it, but how does it know if it's one big pile of items or a bunch of individual items? And it's interesting because if I asked you to build a car, unless you know how to do it, you probably can't do it. But if I give you a box of items you've never seen before and ask you to empty it one at a time, you can do it no problem. It doesn't hurt your brain. You think it's the easiest thing in the world. But the robots have the exact opposite challenge, which is very fascinating. So that's what we're solving. And specifically, what we do at RightHand Robotics is we make robots that can pick up individual items it's never seen before. And this is kind of like the holy grail of the supply chain logistics automation space. You have lots of other automation coming in, moving boxes and pallets of products around, but you still, at the end of the day, you need to move individual items. And This is a huge growing space. Basically, for any company or retail company to survive, they have to compete with Amazon. Amazon making same-day, next-day shipping the norm is totally insane, I think. And so that landscape is changing very quickly, and the reality is there are already labor shortages today. This problem is going to continue to grow. And so that's why we're doing what we're doing, to solve today's needs and then the growing needs. And of course, if we get really good at what we're doing, and again, all we're doing is this, then we can get into medical, more medical applications, at-home assistive technology. But just doing this is so hard for a robot to do. So you should not be concerned with robots taking your job. So this is a short clip of examples of what our robot does. So this is our robot right pick. This is, clips of it in a bunch of different facilities, but in every application, it's just picking and placing. And so what we do is we focus on developing the entire solution. We make a smart gripper. We do all the computer vision, machine learning to enable robots to pick up things it's never seen before. So, yeah, that is what we do.
You can stay there. I'll walk past you. Let's hear it for Nadia. Let's hear it for her. Give me a sense of, what are people working on to try to make this thing work better? Like, what is the work?
It's hard work. We have an amazing team. On our team, so we are a startup. We have about 40 people. Largely, almost all engineers. I actually don't do any engineering at my current company. I love being around people who love robots. So, so we have hardware team. They focus on the gripper. We have a massive software team. Part of that they do. We have folks focused on computer vision. Basically taking the inputs of the cameras and combining that with machine learning to basically, if the robot sees a bin of stuff, through all the learning it does, it's able to make guesses for where it thinks individual items are, and then the system learns strategies for how to pick things up. So all that is in the computer vision learning and software. So it's a challenging problem. Yeah.
So, we are in a time now where we sort of have had automation and computers around for long enough that you can show a video like of that car manufacturing and go, yeah, you see all those machines building those cars? Like, of course machines can build cars. That's not hard, right? But I don't know, like on Henry Ford's assembly line, that would have seemed completely impossible. You're kind of sitting here in 2018 saying, like, the next step, like identifying something in a bin, knowing it's in a bin, picking that specific thing up, putting it over here and closing a box or whatever, you go, that's actually really hard. So don't worry, that's really hard. But, like, is there, like, how close are we to a time when that's no longer hard? Or will it always be hard in a way that the manufacturing thing we now know is not that hard for, say, a robot?
It won't always be hard. The problem we're trying to solve, we're hoping there are a lot of companies trying to do this because the market is there, e-commerce is there and waiting, and they've been ready. The robots just haven't been as ready yet. So that problem will be solved. Obviously we're hoping to do it to beat all our competitors to it. But even once you have that solved, there are things like, so all we do is we pick up and we just kind of drop.
Yep.
Then there are lots of little things out there, like how do you place with precision? So eventually,
so you can pack a whole box as like efficiently as possible
Right,
with
and
as much stuff as possible.
Yeah, and so examples like even like at-home robotics. How can you wash a dish without breaking it? Like you know,
Yeah,
there
yeah.
are things that we take for granted that we can do that are so easy for us. And so I don't have an answer in terms of number of years, but there's still a long way to go, especially for things like a lot of things we find easy day to day that requires all the, you know, everything going on in your eyes and your brain all the way down to your fingertips. Like the human body is amazing. And then, yeah, really.
All right, let's hear for the
Yeah.
human body. All right, yes.
Yes.
Ow! Sing the body electric. Final question. You've mentioned a number of times how much you love robots. Why?
Or people who love robots.
Okay, but why? Why do you love robots and people who love robots? Like, what is the thing?
Well, I was telling a lady over here that I don't know, it's my own journey, I think, but like I like engineers, I think. They're usually very rational, you know. So arguing with engineers, like, okay, like either I get it or I don't. For better or for worse, you know. But I don't know. I mean, I like all other people too. It's not. I mean, I do, like, I've always been I like doing a lot of hands-on creative type things, so I like creating and building, and not that you have to be an engineer to do this, of course, but I've been in this space for a while, and I enjoy it. I certainly love all sorts of other people, too, so, but I am very happy where I am at now. It's just a lot of rational people.
All right, Nadia Cheng, everybody, let's hear it for her. Thank you. We saved this for the end because we figured, you know, have a couple drinks in us, and now it's time to talk about human-robot love. I am very excited about this. I don't really think I need to introduce it any more than that, right? Human-robot love, we've got a science writer, Joelle Renstrom. Bring her up.
So I know this is kind of small, but does anybody know what this is? Tamagotchi. Okay, all right. How many of you had one of these when you were younger? Oh, awesome. How many of you still have one? Just me. Okay. How many of you were upset? You know, okay, maybe you went to school or something like that, and you know, went to sports practice and came home, and the next time you looked at your Tamagotchi, it had little X's over its eyes, and it was dead. Anybody accidentally kill their Tamagotchi? Were you upset when you did it? You're nodding. Were you upset when you did it? Right. What is this? A Tamagotchi. This was made in 96, 97. It was the first virtual pet. It's really not that exciting. It's just like this little blob on a screen, and it wants food, and it wants to play, and if you don't hang out with it enough, it will die. And what ended up happening is that a lot of people, when their Tamagotchis died, they got really, really upset, like really upset, disproportionately upset, right? As we know, humans are not particularly rational creatures, and that's one thing that separates us from machines. And we do get attached to Tamagotchis and to cars and to Alexas, right? And it's only a matter of time, I mean, it's already happening, that we are developing feelings for robots as well. So why is that happening, number one? And number two, and most importantly, what does that mean for all of us? So anthropomorphizing is a pretty natural human tendency. I mean, our only way of understanding something is via our own experience in the world. So we've been personifying, I don't know, the wind or dolls or computers, you know, for a long time. And so it's inevitable that this effect would transfer to robots. One of Sam's colleagues at the MIT lab, Kate Darling, she does some experiments with the Pleo, which is, let's see if we can get this on here. Here we go. Pleo, adorable little mechanized robot. So what she does is she has people play with this thing, and then she says, all right, now I want you to torture it. And the people are like, whoa, absolutely not. And they often can't bear to look if someone else does it, right? So this experiment tells us a lot about how attached we get to objects, especially when we feel some amount of affection for them. And the pleo moves, it makes little noises, and it's pretty clear, you know, the more we feel affection for something, the more we anthropomorphize it. And a good example from our own lives might be, you know, if you think about your favorite toy that you had as a little kid, like maybe a teddy bear or something, if someone were to take that teddy bear and just rip it apart, you would experience some degree of anguish, even though you know your teddy bear can't think or feel, right? There is something in the human brain that, when it comes to our emotional attachment for robots, something in our brains just really overrides reason. And this has been demonstrated time and again, not just anecdotally, but also scientifically. There are researchers in Germany who were also doing some experiments with the pleo, and what they would do is use a fMRI scanner to assess participants' brains when they were watching videos. One video was a video showing humans doing violence to other humans. The other video was one showing humans doing violence to pleos, right? So the subjects did not care for violence being done to humans. They also didn't care for violence being done to pleos. But the most interesting thing was that their limbic systems and their frontal lobes, areas of the brain that are associated with emotion, they responded similarly when the subjects watched those two videos. So it didn't matter whether it was a person being harmed or a pleo, the brain responded in a pretty similar way. Right? And so that's one thing that tells us, oh wow, all right, it doesn't really matter what's rational. You know, our brains have these responses. Some of you might remember, oops, not that one, not yet. There we go, Hitchbot. Hitchbot was this guy right here, this little traveling robot. It hitchhiked all the way across Canada, it hitchhiked across parts of Europe, and then it was going to hitchhike across the US. Started off in Boston, made it as far as Philly before it was beheaded. Right? And people were devastated. I mean, if you just Google this, you'll see how many people really seemed super upset by this. Not only was it a senseless act of violence, but people found themselves really getting attached to that goofy-looking thing. Right? And it's not only the bleeding hearts among us who get attached to robots this way. There are some robots like the Talon 3B that works in war zones. It finds and defuses landmines. And sometimes these robots get blown up, they lose parts, and that's kind of the point. I mean, better that happen to a robot than to a person. But people who work with these robots in the field don't feel that way. Soldiers will award Purple Hearts to robots. They will refuse to leave them behind. And one Army colonel actually called a halt to a military exercise in which a Talon only had one leg left because he said it was inhumane. So the more human-like a robot is in both function or form, the more we tend to anthropomorphize them and get attached to them. So a lot of those social robots that Sam was talking about earlier, some of those are actually pretty good at being human-like, at least in interactions, right? They can identify facial expressions really well. A lot of them can identify not just facial expressions, but eye movements, micro expressions, those tiny little tells that we're not even aware of. Some really sensitive ones can even detect when your skin changes color just a little bit because that indicates that your emotional state is changing. And some of these robots can even respond accordingly. Like if I'm hanging out with a robot and it perceives that I'm sad, it might tell me a joke. Robots also mirror humans, which is something we do starting in infancy, right? We see a baby, we smile at it, it smiles back at us, or vice versa. So robots will mirror humans, and studies show that when robots do that, we bond with them more, and we're more likely to assist them with tasks. And not only do robots mirror us, but we actually instinctively mirror them as well. So there are some people who get a little creeped out by robots that are too human-like. It's a phenomenon called the Uncanny Valley. It's that feeling you get if you're in a wax museum or something and you do a double take. You catch something out of the corner of your eye and you can't tell if it's human or not. That's that kind of freaky feeling that we get, or that some of us get. As Sam mentioned, this is not so much of a phenomenon in Japan. There is a roboticist, his name is Hiroshi Ishiguro, and he built a robot doppelganger that he says has a real presence. And he believes that robots have souls, and he's not the only one. Followers of Shinto believe that any object, from a rock to a robot to an anime character, can have a spirit. And if you believe that robots have spirits or souls, then they're definitely not just tools or machines. So it stands to reason then that it's hardly surprising that we're starting to develop some romantic feelings for robots as well. Yep. So again, a lot of these stories that we hear come out of Japan. There's a man who married a Nintendo DS Love Plus game character. There's a number of others who've declared like a lifelong commitment to robot girlfriends. And this is a French woman who, she uses the term robosexual to describe herself, but she 3D printed this robot partner and intends to marry it and, spend the rest of her life with it. So I guess the big question is, what do all these feelings we have for robots really mean for us? And the answer is, well, a lot of things, potentially at least, especially depending on the timeline. Number one, we do know that robots are going to play many different roles in our lives, from vacuums to pets to toys to colleagues, companions, friends, lovers. Right? We also know that as such, robots could help make us happier or sadder or both or everything in between. This means that we're susceptible to being manipulated by robots, I guess more accurately by algorithms and programming and programmers, not by the robots themselves. This means we might want to consider rights or protections for robots because harm to them causes harm to us. And it does make the consciousness question even more interesting. I'm a skeptic, but some people think that it will be possible to endow robots with consciousness. And if that does happen, well, I mean, who knows what that would mean for our relationships with them. But again, I'm pretty skeptical. What we do know is that human emotion is really a tricky beast, and some of us see it as a weakness because it does make us impulsive and irrational. But at the same time, human survival has depended on emotion for a long, long time, right? And our ability to feel is right now the most important difference between humans and machines. But that gap is narrowing and will continue to narrow as we develop feelings for robots. And even though it is a little far-fetched, I do wonder how robots will eventually feel about all of us. Thank you.
One more time, let's hear it for Joelle. I don't want to hurt that guy. Yeah. This is interesting stuff. So, I find it interesting that for you, I feel like that it would be pretty easy to sort of look at this sort of present future that you're sketching and go like, okay, actually a lot of the stuff you're talking about, we don't have to worry until if sort of robots become sentient, sort of like until they sort of have some sort of consciousness. Then we don't have to worry about grappling with legal stuff. We don't have to worry about grappling with like moral stuff. But you've said, I'm a skeptic that they're ever going to get there, and yet we need to be thinking about this stuff now.
Correct.
Why?
Because it's not just about the robot, it's about us, right? Robot isn't just property. Something like Hitchbot, I mean, that's not like crushing, a piece of property that someone owns. There's more to it than that, and it's not because of the robot, it's because of our feelings for the robot. So hurting that robot hurts us, which means that, yeah, there's something more there than just property. And I also just think that in terms of there being just like a social good, I do think it's pretty important to discourage behavior like, oh, let's just go kick the crap out of this robot because robots, might take over the world and because it's fun.
Yeah, I got to be honest. I'm from Pennsylvania, and I lived
yeah.
in Philadelphia for a long time, and I was like, yeah. Philadelphia kicked the head off of that robot. They sure did. Talking about like humans being irrational. I was like, that's so Philly, which is weird. So, how did you sort of get to the place where like you have an ease and a comfort with this, right? And maybe it's just exposure to writing about it, studying it. Like, was there a point along the way where you were like, oh, this, oh, I heard this story about this thing. That's kind of weird. Oh, that's kind of strange. And then all of a sudden went, well, no, wait a minute. This isn't strange. This is happening everywhere. Like, what was that journey?
It's been weird. But really, in a nutshell, I can say it was all science fiction. I wanted to be a writer. And I thought I'd be a different kind of writer, but I had a certain idea of how good stories are told. And it was a kind of snobby idea of how good stories are told, and science fiction completely changed that idea for me. And the more I started watching, I really quickly made that leap from, oh, this is all crazy, to like, oh, I bet this is already totally happening. And, do a little Googling, do a little research, try to see what's really out there, and then I think, oh my God, why hadn't I heard about this before? Like, I want to stop people in the street and be like, hey, do you have any idea what robots exist out there? This is amazing. Why don't people know this? So I've just, ever since I became a sci-fi freak, which was a long time ago, I've been trying to learn as much about robots as possible.
Can you give a sense of, how common this is? Like, you say something like in Japan they don't have the hang-ups that we have here. As somebody who sort of understands this, has talked to people about this, studies it, how common is it in some of these places where it's quote unquote more common? Are people building these kinds of relationships with robots, and how quickly do you see that sort of filtering throughout other cultures throughout the world?
Well, depending on the infrastructure and the technological development of the place, I do think, a lot of Asian countries are way ahead for a lot of reasons. I mean, Japan is the example that we all keep coming back to, but as Sam said, they have the highest percentage of elderly people of any country in the world, and they do not have enough humans to take care of them. So if you need to adopt a robot or robots to kind of save people or jobs or whatever, you're gonna adjust your thinking really fast. But I also think, Japan they don't use drones, so there's not that association. And in Japanese sci-fi or anime, robots and humans work together to take on the bad guy. And I think all of these cultural influences all together make it such that they think our fear of they think it's just a stupid Hollywood construct. I mean, it's not based in reality at all. And I kind of agree. It makes for some really good stories. So I really think that the biggest thing is just culturally, how all these elements line up. If you're in a country and you've been getting, bombed by drone strikes, or you're worried about that kind of warfare, you're going to think it's the apocalypse, and you're probably not going to be wrong in your specific situation, So I don't think it's a one-size-fits-all thing, but I do think the U.S. is a little slow, will be slow to adopt in some of the social ways. I don't think we're comfortable with the interpersonal sort of stuff with robots.
So you are a writer. If I want to read your writing, where can I find it?
You can find it at joellerenstrom.com, or you could find it at couldthishappen.com. Either place.
Provocative. Joelle Renstrom, everybody.
Thank you.
Well done. I'll take that from you. And thanks again to Joelle and to Nadia, to Sam, all of our speakers. Thanks to you guys for coming out.